We all understand vector components, right? Well, probably not. Here, in this video, I just wanted to show you how to find those pesky vector components without the use of that dreaded, but highly useful trigonometry. Vector components with tools. Let's learn physics. We're going to deal with the force vector. This is 200 newtons at 23 degrees, from the x-axis 23 degrees counterclockwise. Now, these things are the vector components. The vector component, x component, y component. They are perpendicular to each other. They make up the vector. The two add up to, using vector addition, links above, the original vector. So this gets replaced by those two when we're dealing with it. Easiest way to find it using trigonometry, if you have students who understand that kind of thing, is to take 200 newtons times the cosine of the angle, 184, and 200 newtons times the sine of the angle, and you get 78. There you go. That 184 plus 78 gives you 200. We use these vector components often for two reasons. One, for convenience. It's a whole lot easier often to use the x and the y parts components instead of the 200 newtons, because a lot of times you're just moving in this direction or in that direction. All the forces you want are just in the x direction or in the y direction, so you do this for that reason. For convenience, it makes it mathematically easier. Second, those are replacements. They add up to the given vector, that 200 newtons, and you can use them instead of that vector. And make sure that your sketches are to scale, because if they're not to scale, then you tend to make mistakes. That's the quick way to do it. We can force our students to use trigonometry if we want to, but there's a different way that actually makes pretty good sense and is pretty easy to do for younger students, 7th, 8th, 9th, 10th, 11th graders who don't do trig at all, who you don't want to just force to do some random crappy math. Or you can use this method, this new method, as an introduction for your students who will eventually use the trigonometry. Physics, vectors with tools. I need something I can use to draw a flat line, and I need a measuring instrument, and a right angle instrument, and another measuring instrument. The protractor, triangle, and ruler, we'll be using that. Now this thing here is so that I can have a consistent flat line across the board, and it replaces the lines on lined paper or the horizontal lines on graph paper. So lined paper is fine for this technique. You just make sure that you have these tools and your students have the tools too. So now we're going to do the same thing. Measure 23 degrees, pick a starting point like right there. Measure 23 degrees from that point.
3 degrees, line it up properly, check several times, measure 23 degrees.
And then I'm going to get 200 newtons. Meter's too long, so 50 centimeters. Let's try that. Exactly 50 centimeters, with a very carefully drawn back from the tip those arrowheads to maintain that proper length of the line segment with the arrow on it. Then all you need to do is do this.
Line that thing up at the base, draw it straight down, and measure. Up, because that is to the right and up, and then connect.
And now use this to measure and see what the scale gives you.
This turns out to be 46 and a half. 46 and a half, 93, 186. Okay, that's pretty close. 186 newtons. That's 200. 19 and a half, 38, 76. That's pretty good. So 76 newtons.
I'm 2 off here, which is about 1 and a half, 1 3/4, 1 1/4, less than 2% error. And this, I'm 2 off on the 78. It's about 2.5% error. It's pretty good. So this method right here can be used for those individuals who don't do math, really much younger students, to try to get the concept of these vectors, or just as an introduction with the trigonometry added later. Anybody can do this. And remember, we use these vector components as vector replacements. And I think, for me and for many of my students, it does give them a better mind representation of what's going on in the real world. Because this is real. And it gives them better pictures in their brains and helps them interpret the world around them. So get out there and use some tools to find vector components. Get those students to do it too. Thanks for watching Learn Physics. And thanks for that thumbs up too. Really helps a lot. New videos most academic weeks. Subscribe for more. I've even got education ideas, Freaky Physics Friday, and Tech Tip Tuesday. And for bicycles, motorcycles, and family adventures, it's my other channel, Bike Physics. You just learned physics.